Hello everyone, welcome back to Matrix lecture series. In the last lecture, we were discussing exercise 3.2 and we have discussed till question number 12. Today, we are going to proceed further with question number 13. So let's get started. Yes, here is question number 13. In question number 13, what we are given? We are giving a matrices. This is basically a matrices given to us in the form of a function. Okay, so this is basically a matrices which is a function of x, right? What is our task? Our task is to find this and this, and finally we have to show that both this part and this part, that is LHS and RHS, both are equal. So let's do one by one. Let's first solve the left hand part. Okay, in left hand part we have fx and fy. Basically fx and fy, both of them are matrices, right? So our aim is to multiply both of these matrices because there is no sign between them, therefore it is multiplication here, right? So fx is already given to us. Let's find fy first. Fy, basically what is the difference here? We have f of x, therefore all these arguments of our trigonometric functions are x, but when we are finding f of y, so all these become y, that is it become cos y, it becomes sin y, cos y, right? So there will not be much change, just the change in the argument. So let me directly find the fx and fy, the product of both of these. So how will we do product? Let's see with this question also. Let me first write the matrices given to us. So here I have cos x minus sin x 0, cos y minus sin y 0, then sin x, cos x 0 1 0 0, here sin y, cos y 0 1 0 0, right? How we multiply? As you know, we will multiply this row with this column. Okay, so if I multiply, what will I get? I will multiply these terms. So cos x into cos y, cos x into cos y, then this sign will be multiplied with this sign, so I get sin x into sin y, and this is 0. So this is the first entry which I will get. I think there is a very little space here, so let's see. Okay, when I multiply this row with this column, what will I get? I will get minus sin x minus sin y cos x. Let me write it in smaller because the space is very less here, or I can also use text box. What I get? Let me write via using text box. Okay, so I will get here cos x times cos y, which will be subtracted from sin x and sin y. Okay, this is my first entry. What will be my second entry? My second entry will be minus cos x sin y minus cos x, and the remaining part will be 0, right? How? Let me explain you. Okay, let me explain you. One by one. When I multiply this row with this column, what I am basically trying to do, I will multiply this cos x with this cos y, so I get cos x cos y. I multiply this sin x with sin y, I get minus sin x sin y, and when I multiply this 0 with this 0, I get 0. So I have not written it, right? Now next, when I multiply this row with this column, I will multiply this cos x and this sin y, so I get minus cos x sin y. Then I will multiply this sin x with this cos y, so I get minus sin x cos y. So let me write it. Let me write here minus sin x and cos. Now it will be adjusted there, cos y. Okay, this is what I will get here. I hope it is clear to you, right? Now you can very easily see it. This is my matrix which I am trying to form here. This is a matrix, and this is the first entry, this is the second entry, third entry will be 0. Why it will be 0? Because when I multiply this cos x with 0, I get 0. This sin x with 0, I get 0. This 0 with this one, I get 0. So all will become 0. Now this row is multiplied with this column. Okay, when I multiply this row with this column, what I will get? As you can see, I get sin x cos y, cos x sin y. So I get sin x cos y plus cos x sin y. This is what I will get. Okay, now I will multiply this row with this column. When I multiply, what I get? I get minus sin x. I get minus sin x sin y and plus cos x cos y plus cos x cos y, and also this last entry will be 0. Why? Because this sign when multiplied with this 0, I get 0. This cos when multiplied with this 0, I get 0. This 0 multiplied with 1, I get 0 again. So last entry will also be 0. Now if I multiply this row with all these columns, what I will get? I will get, you can see here, I will get 0 here, 0 here, and finally 1 here. Why I will get 1? Because when I multiply this one with this one, I get 1 here. Okay, so I get 1 here. Let me write it with some space. 0 here, 0 here, and 1 here. Okay, here is a negative sign also. You know this thing, that there here should be a negative sign also. So here is a negative sign, right? This is my matrices. This is my basically left hand side. This is my left hand side. Now what I have to find? I have to find f(x plus y). Okay, what is f(x plus y)? F(x plus y) is nothing but simply change this x with x plus y. So my all these arguments, the arguments in all these trigonometric function will change to x plus y instead of this x, right? So what I can write, f(x plus y), let me write it on the next page. F(x plus y), what I will get? I will get cos x plus y minus sin x plus y, 0 here. Again these entry will remain same. Okay, these remain 0 1 0 0. I here get sin x plus y, here cos x plus y. Now this is my fx plus y. Okay, what is next I have to do? I have to show that both LHS, this is my LHS, right? This is my LHS. I have to show that both LHS and RHS are equal. Now in the first glance you might be thinking that they are different, but no, they are not different. Actually, if you use the identity of cos x plus y, which is what? Which is cos x cos y minus sin x sin y, then you will see this first entry is same as this entry. See, cos x cos y minus sin x sin y, right? Both of them are same. Both of them are same if we use this entry. Now if I use the formula sin x plus y, what is the formula? Sin x cos y plus cos x sin y. Now when we use this formula, we can say that this entry, see here is a negative sign also, so basically both of them will become negative. Instead of plus, both of them will become negative. So you can see that this entry, now this entry, this second entry is equals to this entry. See here it is minus cos x sin y minus sin x cos y, so they both are same, right? Similarly, you can go ahead with this entry and this entry, and you will find that both LHS and RHS are equal. Hence proved. This is what we have want to show. Hence we have proved that both LHS and RHS are equal. I hope this is clear to you. Just you have to keep in mind these two formulas, which you might have remember also, right? Just remember all these formulas, that's it. Here the actual formula is of positive, but since due to the negative sign here, it will become negative. Okay, this is how this question will be done. I hope it is also clear to you. Now let me erase it and let's move to the next question, which is question number 14. In question number 14, what we have asked, we have actually asked that we have to show both these LHS and RHS side are not equal to each other. So basically this question is also very easy. Just first simplify this LHS part, then simplify this RHS part and show that both they are not equal. When they will not be equal, when the corresponding entries are not same, only then they will not be equal. Now simply multiply the LHS. Let's solve the question number 14 and the LHS part. What are the matrices given to me? It is 5 minus 1 6 7, here 2 1 3 4. If I multiply, let me first remove this also. So I multiply it in the similar way. I get 10 minus 3, which is 7, then 5 minus 4 is 1, then 12 and 21 is 33, and then 6 and 7 4 28, and 6, that is 34. I hope there is no any mistake. Yes, 34. Yes. Okay, this is my left hand part. Okay, my right hand part is 2 1 3 4 and 5 6 7 minus 1. Let me multiply this also. So what I will get here, I get 10 and 6, which is 16, and minus 2 plus 7, which is 5, 15 and 24, it is 39, minus 3 and 28 is 35. this is 39. Now if you see that this first entry itself is different, here it is 16 and here it is 7. Since the first entry itself is not same, hence we can say that LHS is not equals to RHS, because for the equality we know the condition that each and every corresponding entry should be same, but since they are not same here, even the first entry is not same, hence we can conclude that these matrices are not equal. Hence we have proved this, right? Similarly, you can also do the second part of this question, which is a 3 by 3 matrices. Simply product this, and you will find that both of these are not equal, and as a result you will be able to show that they are not equal. That's it. Now comes the question number 15. Actually, if you examine this, both question number 15 and question number 16 are on similar lines. In both these we have to find a sort of equation. Now don't get worried after looking at this equation. Just break it into smaller parts. A square, what is a square? A square nothing but multiplication of a 2 times, right? We are given with a matrices, we will multiply it with itself, we get a square. Okay, then minus 5a is nothing but the multiplication of a matrices with the scalar minus 5. We have already given with the a matrices, we will multiply it with minus 5 and we get minus 5a, right? Then 6i, that is multiplication of 6 with the identity matrix. Now in our case, since a matrices is a 3 by 3 matrices, so identity matrix will also be 3 by 3 matrices. We will consider this particular identity matrix, right? So we can very easily find all these separate parts and then add up to find the value of this equation. What will be the value of this equation? The value of this equation will also be a matrix. Okay, let's solve this question. So we have to first find a square, that is I have to multiply this matrix 201 213 1 minus 1 0 with itself, that is 201 213 1 minus 1 0. When I multiply, what will I get? Let's see, 2 to 4 and 1, which is 5 0 0 and minus 1, so it is minus 1 here, then 2 0 and 0, so 2 here, then 4 2 and 3, which is 9, right? 4 2 and 3 is 9, then 0 1 minus 3 is minus 2, then 2 2 3 2 and 3 5. Okay, 2 minus 2 is 0 and 0, it is 0, and this becomes 0, this will become minus 1 and this becomes 0, so I get minus 1. 1 minus 3 is minus 2, so I get minus 2. 1 minus 3 is minus 2. Okay, so this is my matrix. This is a square. Now what is minus 5a? Minus 5a is simply multiplication of this a matrices with minus 5. What is my a? This is my a matrices, you know very well. So I will simply multiply each and every term with minus 5. Okay, when I multiply it with minus 5, I get minus 10 here, because 5 to 10 0, minus 5 minus 15 0 plus 5, I get here as minus 5 minus 10 and minus 5 here. This is what I get. Now I have find it minus 5a, I have find it a square. Now what's remaining? 6i. 6i is very simple. 6i is basically 6 0 0 0 6 0 0 0 6. This will become 6i. You know very well how it becomes 6i, right? Now what is the next step? Next step is to add all these, because I have to find this, I have to find the value of this. So simply add all these matrices. After adding, let me add here it is 6, here it is minus 10 and 5. So what I will get? I will get 1 here, right? 0, 0 and minus 1. So I will here get minus 1. Next I have 0 here, minus 5 here and 2 here, which gives me minus 3. I got minus 3. Similarly, I will add and I will get these entries. This is my required answer. Isn't it simple? It is simple. Simply I have just break it into various parts and then add it. Finding each part is simple, just a small calculation. After that you can add all these parts and we get the value of this equation. Or what will be the value of this equation? The value of this equation will also be a matrix, right? I hope this question is clear to you. Similarly, you can do this 16 question. Let me give you a hint. In this there is a part a cube. So a cube, how will you find? A cube means multiplication of a 3 times. First multiply a 2 times, then multiply again it with a, you get a cube. Then 6, then you have to find minus 6a square. Basically find a square first, then multiply it with minus 6, you get minus 6a square. Okay, then 7a, multiply 7 with the given a matrices. What is the given a matrices? This is the given a matrices here. Also you can easily find 2i. What will be the 2i? 2i is the multiplication of 2 with the identity. What is the identity? Identity is this matrix. Okay, so you can find individual parts and then you can add all these. What you have to prove? Actually, after adding all these, you will get 0. What does this 0 represent? This 0 represents a 0 matrices, that is a matrices of this type. You have to actually prove it. That means you will eventually get this matrix only after adding all these various components, right? So this is very simple question, just a little bit calculation, right? Okay, fine. Now moving ahead to question number 17. In question number 17 we have a matrix and I. We have to find k so that this holds. Now this type of question is also quite important. All those questions in which we have to find some value, whether it be the value of finding x or these x, y, z, t, such questions are important. Keep in mind. Let's find this question number 70. Let's solve this question. In question number 17, so basically we have given with the a matrices, right? Let me first erase this. Okay, now let's come to the question. In question here we have given a matrices and I matrices. I have to find k so that this equation holds. I know that this equation holds. I have to, using the property that this equation holding, I have to find the value of k. Okay, so question number 17. Again, part by part we will solve each component and then put it in the equation. A square, what is my a square? My a matrices is 3 minus 2 4 minus 2. I have to find a square, so I will write again 3 minus 2 4 minus 2. What I will get after multiplication? I get 9 and 4 to 8, which gives me 1. So and minus 6 plus 4 minus 2, right? And 12 minus 8 gives me 4. Minus 8 plus 4 gives me minus 4. This is a square. Okay, ka. What is ka? Ka will be 3k minus 2k 4k minus 2k. How I have find it? I have simply multiplied this A matrices with K, the scalar element K. When I multiply this 3 with K, I get 3K. Multiply minus 2 with K, I get minus 2K. This is how it will be done. Right. Now let's find 2I also. 2I is 2 0 0 2. Now if you notice what I have used here, the I which I have used here is 1 0 0 1. This is the I which I have used here. Why I have used this I? Because my A, the given matrices, okay, yes, my given matrices is of order 2 by 2, therefore my I is this matrix, this 1 0 0 1. Okay, if A was of order 3 by 3, then I will use the matrices of order 3 by 3. Okay, now simply go with this equation. Here it is saying A square is equals to Ka minus 2I. So let me first find Ka minus 2I. Ka minus 2I. Let me write it here. Ka minus 2I. I know what is my 2I is. So what I get? I get 3K minus 2. Here I get minus 2K and 4K minus 2K minus 2. Right? This is what I will get. Now I have to make it equal to this value of A square. Okay, so basically since they are equal, then 1 will be equals to this. If 1 is equals to this, that means 3K minus 2 is equals to 1. This means K is equals to 1. Right? If you go with other entries also, that means 4K should be equals to 4. This is also giving me that K is equals to 1. If you go with this entry minus 4 and this entry, you will again get K is equals to 1. Hence my K value is 1. Okay, my K value is 1. Now if in case you got some different K by comparing some different entry, let's say if I compare this entry and this entry, this is supposition. Okay, here in this case they are coming out to be same, K equals to 1, but if they were coming out to be different, let's say it will come out to be K is equals to 2 with some other entry, by comparing some other entry. In that case I will say that my K has no fixed value. Okay, now but in our question K value is fixed, so K is equals to 1 is the answer which we will report. K is equals to 1 is the required answer. This is what we have asked. We have to find the value of K, and we have found the value of K. The value of K is 1. Right? Next question. If I see question number 18, here we have to show this thing. Okay, I have given A matrices and I is the identity of order 2 by 2. It is given order 2. Why it is given order 2? Because identity matrix is a square matrices, and in square matrices we know that number of rows is equals to the number of column. So basically when I write 2, it eventually means that the number of rows should be equals to number of column, because after all it is a square matrix. So in short we can write that the matrices have the order 2. This is same as saying matrix has the order 2 by 2. Okay, that's why it is written in this manner. Okay, we have to show that I plus A is equals to I minus A times this. This is again also similar question. First solve the LHS part, solve the RHS part, and then show that both the sides are equal. How we will show? We will check the corresponding entries to show this. First simply add I with this. Let me solve this question by creating some space. Okay, so question number 18. my A, the matrix A which is given to me is this 10 alpha by 2 0, and here I get minus 10 alpha by 2. I have to add the identity matrix. Okay, when I will add the identity matrix, what I get here 0, here minus 10 alpha by 2, here 10 alpha by 2, here 1. Why? Because you know that identity is this. We are given that the identity is of order 2 by 2, so simply add them. When you will add, you will get this matrix. You will very easily find this. Okay, now I have to find I minus A also. See, you can see here I have to find I minus A also, because then only I will multiply it with this given matrix, right? So let me find I minus A also. I minus A will be 1. Okay, and how it will be changed? 1 0 0 1 minus this very A matrices. Okay, so okay, let me write it I minus A directly. When I subtract 0, I get 1. Then 0 minus this, I get here 10 alpha by 2. Note that here the sign of alpha by 2 has changed because I am subtracting it. Therefore, the sign will change, right? Be very cautious here. Then 0 minus this, so again here the sign will change, alpha by 2, and 1 minus 0 is 1. This is what I will get. Okay, now next step is I have to multiply this matrices with a given matrices. What is my given matrices? This is a sort of matrices which is given to me, minus sin alpha, and here I have cos alpha. I have to multiply this, right? I have to multiply this with this. This matrix is this matrix which I have find it here. Now let's multiply it. When I will multiply, what I will get? Okay, so I will multiply this row with this column. As a result, I will get cos alpha plus, when I multiply this by this, I get, here is a negative sign, no negative sign here, so 10 alpha by 2 sin alpha, right? Similarly, I will multiply this row with this column. Let me write it a little bit smaller. I get cos alpha plus 10 alpha by 2 sin alpha. Okay, when I multiply this row with this column, I get minus sin alpha and plus 10 alpha by 2 cos alpha. I hope it is clear to you. Now I will multiply this row with this column. When I multiply, I get minus, I get here a negative sign, minus 10 alpha by 2 cos alpha and plus sin alpha Now I will multiply this row with this column. What I get? I get 10 alpha by 2 into sin alpha, okay, plus cos alpha. This is what I will get. Now I have to simplify it. Now how I will simplify it? I will use some formulas. You might have remembered this formula, that sin 2 theta is 2 sin theta cos theta, right? And also cos 2 theta is equals to, can we use some formula for cos? Let's see, here I have 10 Okay, I have cos here, so let's find it later whether we have to use it or not. So when I use this formula, okay, when I use this formula here, what I will get? I will get 2. Here the sine will be replaced, sine alpha will be replaced by 2 sine alpha by 2 into cos alpha by 2. Okay, and this tan can also be replaced by sine alpha by 2 and cos alpha by 2. As a result, what I will get here? I will get here 2 sine square alpha by 2, right? Similarly, what I will get here? Here I am talking about. Here also it will change to 2 sine square alpha by 2, right? Now here I have cos. I think I need to change this cos as well. Let's see. We know that cos 2 theta is equals to cos square theta minus sine square theta. Okay, can we use this formula here? Maybe we cannot use this formula. We also know that this is equals to 2 cos square theta minus 1 also equals to 1 minus 2 sine square theta. Now which formula can we use here? Let's try to get a hint from left hand side. Okay, what is my left hand side? My left hand side is this one, I plus e. I have to get 1 here. That means here I should get 1. When it will be 1, we need to examine that if I use the formula of cos here, if you notice, if I use the formula of cos here, which formula? This formula, then I will get 1 here, right? Because cos theta can be written as 1 minus 2 sine square alpha by 2. How? By using this formula, right? So I can very easily replace this with 1. In this way, if you try to do in this way, then you need not to memorize. You just simply have to look that what is our aim. Our aim is to reach to 1, and we have reached 1. How we have reached? By using simply, okay, it is erased, I guess so. Yes, now it has came back. Yes, what I was saying that you have to see that what is our aim, where we have to reach, and accordingly you have to change it, right? Similarly, again go back here, we also have to get 1. Therefore, what I will do here, I will again use the same formula and I will get here 1 again, right? Now next task is to convert this as minus tan alpha by 2 and plus tan alpha by 2. Okay, I have to convert it as minus tan alpha by 2 and this as plus tan alpha by 2. Let's see. Let's try to do this. I have cos here, sine here and tan alpha by 2. Okay, if I use the identity of cos, which identity of cos should I use? I have to use in such a way that I get left with this tan and this sine is also get removed. Okay, now I guess you have noted down all these formulas, so let me erase it. If you have not noted it down, please do so. I am showing to you. Okay, note down both these formula. Okay, now you might have noted it down. Let me erase it and let's try to work on it. Here it is 1. Now what is my task? My task is to change this sine alpha minus sine alpha plus tan alpha by 2 cos alpha into minus tan alpha by 2, because here I have minus tan alpha by 2, right? So this sign can be written as minus 2 sin alpha by 2 cos alpha by 2. This tan can be written as sin alpha by 2 upon cos alpha by 2, and this cos can be written as cos square 2 cos square alpha by 2 minus 1, right? If I again simplify it, what I get? I get here minus 2 sin alpha by 2 cos alpha by 2, and if I simplify this part, what I will get? I will get plus 2 sin alpha by 2 cos alpha by 2 minus sin alpha by 2 minus sin alpha by 2 upon cos alpha by 2, right? This is I will get, and these both part will cancel. I will left with this, and what is this? This is minus tan alpha by 2, right? Let me again show you. When I multiply this part with this part and this part, what I will get? See, carefully look at this. I will get 2, this 2 will remain as it is, this one cos will cancel with this, so I will left with sin alpha by 2 and cos alpha by 2, right? And beside this I have this minus 1 also, which I have to multiply it with this part, right? When I multiply it, what I get? I get the same with negative sign, sin alpha by 2 divided by cos alpha by 2. Now if you examine, this part can be easily cancelled with this part. Here it is of negative sign, here it is positive sign, so both this part will cancel. What I will remain with? I will left with sin alpha by 2 upon cos alpha by 2 with a negative sign, and what it would become? It would become minus tan alpha by 2. This is our aim also. We have to convert it into minus tan alpha by 2, and how do we know it? We know it from here, right? Here it is minus tan alpha by 2, so it will become minus tan alpha by 2. Similarly, you can do this and it will turn into tan alpha by 2. If in case you have not cleared, just again watch the video and try to understand. I have not used anything new. I have just simply used the formula of sin 2 theta and cos 2 theta to find this. And how I got to know that where I have to reach? I have got to know from this only. In the question we have said that we have to show it. Now let me again show you the question, that we have to show it. That means this would equal to this definitely. We have to show it. So we know what is our aim. Then simply find it. I hope this question is also clear to you. Now we are remaining with 4 more questions. We will discuss it in the next lecture. That's it for today. Try to do these questions by yourself. In case you have any doubt, you can write it in the comment section, and you can also connect with us via various social media handles. Thank you.